Hi class, we have the 15th lesson for logarithm. We have a lengthy problem here we want to solve. The question says, given that this plus this equal to r minus 1/3 and this minus this equal to 2r plus 1. With these two equations given, there are two things we must do. One, to show that p squared is equal to this. Two, with additional r equals to 1 given, we are to find the possible values of p and q. Okay, so what we do is, this equation, the log that is there is what in base 8, as well as this log here, base 2, base 2. So it's somehow tricky for us to combine them in form of log. So what we do is, since what we want to show there is no log, let us try to eliminate log here. Here again, we'll try to eliminate log. So the first one says log p plus 2 base 8 plus log q base 8 equals to r minus 1/3. Okay, so base 8 will take 1. Because of plus, what happens in log? We multiply them. Q multiplied by p plus 2. Remember, when multiplying, 3 times 2 is the same as 2 times 3. So this one comes before this, but because of this one is an expression, I decided to write this one first, which is equal to r minus 1/3. Okay, but here, we used to have this one that says log a base b equal to c. So the log number is this, which is a equal to b to the power c. So here again, this is the log number, q into p plus 2. That is the log number, just like how the log number is here, equal to b to the power c. So this to the power this. So 8 to the power r minus 1/3. The power is an expression, do not forget. Okay. So let us label this as the first equation. The second one says log p minus 2 base 2 minus log q base 2 equal to 2r plus 1. Base 2, we are lucky, we take 1. Yeah, we've taken 1. Because of minus, what do? We divide. It is unlike here to say, when we say we multiply, you write this before this or you write this before this, no problem. But here, when we are dividing, this has to be the first one. It's a must. So because of minus, we divide. P minus 2, this one, divided by this q here, which is 2r plus 1. I hope it is clear. So what I just insinuated here, this is the log number, which is p minus 2 over q, which is equal to 2 to the power this, 2r plus 1. This is equation 2. So we've succeeded in eliminating log on both equations. But this is what we want to show. So what is next? Okay. Now, this one and this one, they look alike. This one is in exponential and this one is in exponential form. So what do we do now? We multiply them. This one multiplies this one multiplies this. So we say equation 1 multiplies equation 2. So when two equations are multiplied, what do? The left multiplies the left. The right multiplies the right. I hope it is clear. Okay, I don't want to remove that one. Maybe we need it. We need something there. So what do we do now? The left here is Q multiplied by P plus 2. So this one multiplies the left here. P minus 2 over Q. So what else? The right multiplies the right. 8 to the power r minus 1/3 times the right here is 2 to the power 2r plus 1. 2r plus 1. So this takes away this. So we are left with p plus 2 times p minus 2. The base is 2. The base is not 2. So we can generate base 2 here. So 2 to the power 3. Just the 8 is 2 to the power 3. Multiply by the power that was there, r minus 1/3. This is still 2 to the power 2r plus 1. The first are the same. The second are the same. The signs are different. This is difference of two squares. So p times p is p squared. We take minus 2 times 2, 4. Okay. So this and this, they have the same base. We take 1. What happens to the power? Because of multiplication, we add the powers. So here is 3 times r, 3r minus 3 times 1/3. 3 times r is 3r. 3 times 1/3, look at it. 3 times 1/3. This takes away this. So what is 3 times 1/3? It's just 1. Okay. This is for just this one. But we've decided this and this are the same, so take 1. So because of multiplication, we add. So we say plus 2r plus 1. I hope you see it, eh? So this is p. This is p squared minus 4. This is 2 to the power minus 1 plus 1 will go away. So 3r plus 2r is 5r. So p squared minus 4, 2 to the power 5 is 32 to the power r. Look at what we want. But p squared is standing on one side. So we say p squared equal to. We can allow this one to start, but because we want it to appear like this, so we send minus 4 first to become plus 4. Plus 32 over r. So we've answered the first part of the question that says show that this is equal to this. This is what we have. So what is next? Excuse me. Okay. So what is next? If r is equal to 1, so if r is equal to 1, what happens? We get p squared equal to 4 plus 32 raised to power 1 because r is 1. So p squared equal to 32 to the power 1 is what? Is 32. 32 plus 4 is 36. So finally, to find the values of possible values of p and q. All right. To find the possible values of p and q. So what do? We ignore the square. Once we ignore the square, we take the square root of the other side, which is 36. Which is what? 36. So what do we do here now? We say p is equal to plus or minus 6, because square root of 36 is what? Is 6. So p is 6 or minus 6. So what is next? The next thing is to find what? Q. Where can we get Q? We can go to any equation where there is Q. Yes, we can go to any equation where there is Q. So let us consider 1 and 2. Which one do you think we are to consider? Here is a fraction. Here there is no fraction. So I advise what? Let us don't forget R is 1. So let us see. If R is 1, 1 minus 1/3, it will give us 2/3, which is still fractional. So I think we can come to this one here. So we say from equation 2, 2 says P minus 2 over Q equals to 2 to the power 2R plus 1. Yeah. So what is P? So we say if P is 6, then R is already 1. R is 1. Then we can say P is 6 minus 2 over Q. We want to find Q. 2 to the power 2R. 2 times R, but R is 1 plus 1 here. So 6 minus 2 is 4 over Q. 2 to the power 2 times 1 is 2. 2 plus 1 is 3. So 4 over Q equals to 2 to the power 3 is 8. We give this 1. I hope it is clear. So 4 times 8 is 8Q. 8 times Q, not 4. Q times 8 is 8Q. 4 times 1 is 4. So divide by 8, divide by 8. So what is Q? Q is half. Q is what? Is half. Okay. So we say P is 6, then Q is half. Okay.